Hello, my name is tbaldridge. I'm a developer with Cognitect, and today I want to talk a little bit about deep walking macros. The question of how deep walking macros work and how they relate to my work with the Go macro and core async has come up several times on the Clojure mailing list, as well as on the IRC channel. So I want to talk a little bit about deep walking macros today. In this video, and then probably in a later video talk more about how the Go macro uses these concepts to a little bit further extent than you will see today. So let's look at something interesting. Let's look, for instance, at a simple expression. So we are going to add the square of a with a, or the multiplication of a with a, and the square of b, right? So this is normal Lisp. We're used to this sort of thing. And as we know, as Lisp developers and Clojure developers, these forms are simply data, right? We have a list with symbols in them, and we can manipulate that sort of thing. So at the basis, at the core, macros are simply a way of transforming these lists before they are actually seen by the compiler. So we have the reader, the macro expansion, and then the compiler. Let's write ourselves a macro today. I'm not going to assume that you've ever written a macro before, so let's just do that. So we're going to put this in a comment so we can still compile this, and we're going to write something called only ints, and we're going to give it a few numbers, 1, 2, 3, and 4, and it's going to return a vector of 1, 2, 3, and 4 if every single argument is an integer. If it's not an integer, then this won't even compile. We won't even be able to compile this the code. We'll get an exception. So let's give this a try. We create macros by calling def macro. It looks more or less like a function definition, but the arguments that are handed to it are unevaluated. And we'll see how that differs in a little bit here. So we're going to def macro only ints, and we're going to take a variable number of arguments. And then we're going to assert every integer args. So we're going to say every one of the args has to be an integer, and then if that happens, we're going to vec args. So we're going to convert it into a vector. So we can compile that, and then ns will go deep walking macros, and we can do only ints 1, 2, 3, and 4. That works. And if we were to go in and replace this with s, we get an assertion. Every integer args. We have to have an integer. Now, I said this only will work, right, if this happens at compile time, right? So what does that mean? Well, let's take a look at that, right? Let's put this in a def-n. So we'll call this our test function. And we're going to have, we're actually going to give this x here. And ints x. Now, when we try to compile this, we say, whoa, this is an exception. This exception happens because x is not an integer. Well, let's do something a little bit different, though. Let's do def-n only ints fn. So we're going to write this as a function and do the same thing. Assert every integer args. Now, functions are run at runtime, right? So if we compile this, only ints the function version, it works just fine, right? And in fact, if we come back here and we do our test function, so let's do that, test fn, and we hand it 42, it works. And if we hand it s, it fails, right? So that's runtime failure, because it goes into the function here, and it'll pass or succeed because this only ints check is happening at runtime. However, let's switch that back to the macro, and once again, it won't even work because it's being handed is the unevaluated arguments, which in this case is the symbol x. Okay. So what does this really give us, right? What good does this do for us at all? Well, it just so happens that Clojure is based off a very small set of primitives. If, do, loop, recur, the dot form, and a various system, the try catch, a few other things, right? But there's sometimes we want something more complex, right? How many of us have done this? When something's true, do this and this, right? So the Clojure form for if only accepts 3 arguments, right? We have if, test, then expression, else expression, right? But we want a multi-line here in the then, right? So what we sometimes do, we'll do a do form, then this, and so on and so forth. So the when macro in Clojure, it's just that. It's a macro. Let's write that real quick. Let's see what it would be like to write that. So first of all, def macro when, and this is going to take a test and body, right? So we're going to have a variable length body. Now, the output of a macro is inserted into the is inserted in place of the form where the macro is called. And let's look at that real quick. Let's actually stop here real quick and recompile this. And we'll take this out. Okay, so here we're going to try our 2 different versions here. There's a thing called macro expand. Macro expand is the friend of any developer of macros, right? Macro expand. So what macro expand does is run the expansion without actually executing or running the code. So if we do this, only ints 1, 2, 3, and 4, we get an actual vector. Whereas if we do only ints fn, we get the actual form. Only ints fn is a function, therefore it cannot be expanded to anything, and we get the same output. So, but in the only ints macro that we see over here, right, it actually returns a vector, so it does it in place. So that's kind of the cool thing, is you can actually have a macro do a whole bunch of compile time checks or that sort of thing on the code, and it could spit out very complex forms, but that only happens at compile time. Think, for instance, if you had a SQL database, it would be possible, maybe not wise, but it would be possible to write a macro that would spit out a whole bunch of types for the different tables in your SQL database at compile time, right? And so the reflection over the SQL database would happen once when you compiled your system and wouldn't happen after that. So it's kind of runtime code generation, or compile time code generation. All right, so let's go back to what we had here. So we have this when macro, right? So we have test and body. Now we're going to dive into something a little bit fun called splicing, the splicing quote, right? But let's see here. To start with, or syntax coding, we're gonna look at how this works. So syntax code is backtick, and then we're gonna do an if, and tilde x, or tilde test. And what this says is, take the value we received in test and splice it in to this part of the list. So we're kind of building a template. If anyone's ever used HTML templating, it's exactly what we're doing here. Okay, and then we're going to have do, and we are going to execute this wrong the first time, so we can see the difference here. And we're going to do body, and then we're going to return else. So this is just actually we'll return nil in the other case. So this, if it's true, we're going to execute the body. Otherwise, we're going to do nothing. And it warns us here that when is being replaced, but because when already exists in Clojure. But we'll deal with that. So we do when true, and then 42, and we get this exception here. What does that mean? Well, macro expand is our friend, right? And we have to quote this, because if macro expand is a function that we hand this form. So if we do if we call it just like this without quoting the second form, the when true 42, we'll get the same error, because it's trying to evaluate when true 42 and then hand that result to macro expand. So let's quote it. So we're actually handing it the data, and we get this. Ooh, ouch! Look at that. So it says if true, do, and it's trying to call 42, and that's the error we're getting. Long cannot be cast to an IFN. There's no way to call long as if it were a function. Well, that's because of this bug that I intentionally put in here. So body that we're handed here is a expression, or is a sequence of items, right? And we really don't want to put in the sequence. We kind of want to expand it. We want do and then do const on to the beginning of our body sequence, and that's what this does here. This and the at sign is it says kind of explode body into the current position it's at in the syntax coding template. This is really weird stuff, but pretty important to grasp. So we'll compile that and run it again. And now it works. So if true, do 42, nil. So now let's run this. Boom, works just like we wanted. And we can actually do this. So print line hello, and then return 42. And we get the two outputs. And if we macro expand that, we can print line hello and do that. And we can see that it properly inserts that into the do. So this is a normal macro. Right? This is a macro that simply evaluates the current form. There's a couple other things here that are interesting. One of them is the environment. So there's a symbol in macros called environment. And we're going to print that out. It's env pound, I think. I only actually use this once in a great while. Let's see here. Yeah, that's not it. It's let's see, and env. You know what? We may not have to deal with that for a little bit. So I'm actually gonna, that we might deal with that in just, actually no, I'll tell you how we can figure this out. Once again, macro expand is our friend. Def macro is a macro. Cool side note. The fact that I don't remember what this is a testament to how little I actually use it. And it's only when you're doing deep walking macros and yeah. So macro foo, let's give it nothing and return 42. And it expands into this. So here we go. It's and env. So what's interesting is macros expand to a function that has some extra metadata on it, and then it has and env and form. So we can actually let's do and form to take a look at that. So let's recompile that and re-expand. So here we are actually, and during macro expansion, printing out the input form, which is kind of cool. We have access to that. And then we also have this other thing here. There we go. Which is currently nil. And I'm not exactly sure why that's nil. We'll have to think about that. Oh, I know. The environment contains local variables. There are no local variables at this point, so it's kind of pointless. But we'll deal with that in a little bit because we do use that inside some other functions. I think we might actually get something if we do this sort of thing. So fnx, there we go. So the environment is a hash map of symbols to what the symbol references. So inside your macro, you can actually get a list of all of the local variables, the local bindings that are available to you. And this has some implications in the Go macro that we'll talk about later. So all we really need to know now is that macros are actually functions that take at least two arguments, most of the time 3 or more. Those are the form, the environment, and then the kind of the arguments passed to the macro. So let's look at something else here. Let's do meta off of pound quote when. So this is the meta of the var that we created called when. Okay? And if you'll notice here, it says macro true. That is actually the only difference between a macro and a normal function, is that when def macro creates a normal def end, and then at the end sets the var to macro true. So when the compiler is executing and it looks for a function invocation, like we had here in the when, it looks at it and says, what is when? So it goes off and finds the var that when represents, finds it and says, is this set to macro true? And if so, then it takes the form, feeds it through the function, takes the output, and does that again. Is this now still a macro? Yes, then it does it again and again and again. And the cool thing about that is if you see here, like the def macro actually spits out def n, right? And def n itself is a macro that expands to def and function. And so there's kind of this recursive type thing going on. All right. So that's cool. So that's the basis of macros, right? That's the way macros operate on a common level. Those are not deep walking macros. They're just normal macros. So what is a deep walking macro? A deep walking macro is a macro that doesn't just analyze the top level form, but also descends into its children, right? And keeps going deeper and deeper and deeper. These macros are often very complex. The macros we have here are just a couple of lines. It's not uncommon for most macros to be 10, 20 lines long, maybe. The macros for core async, the Go macro is roughly 600 lines of code. There's a lot there. And when you start dealing with these deep walking macros, you start going into the realm of writing small compilers, which isn't necessarily a bad idea. It often is, but it's a tool. It's a tool. So it can be used in interesting situations and abused in many more situations. All right, so let's have some fun here. Let's write ourselves a deep walking macro. All right. So first thing I always do when writing a deep walking macro is I write myself two multi-methods, def multi, and we'll call this a parse item. And multi-methods take a function to dispatch off of. So the function we have here is going to be handed something, right? Some sort of form. So what we're going to have is form followed by some sort of context. So CTX. Now we're not actually going to use the context in this little form in this little function here, but we need it there so that it executes properly. So now we're going to do this. We're going to do cond and say if seek, if form is a sequence, then we're going to return seek. If it's a integer, then we're going to return int. And if it's a symbol, we are going to return symbol. Okay, now there's a lot more possibilities of what actual code could be that we hand to this function, but we're going to start with this for now. Start simple, right? And the other one we have is def multi. And this says parse sexpr, so s expression. And this is going to have a form like this. It's going to be sim and rest, and then we're going to have the rest be CTX, and we're going to actually dispatch on sim. All right, now let's write our first invocation of this def, or our first override or method here. Def method of parse item. If we are handed a sequence, then, and this looks like form CTX, then we're just simply going to go and call parse sexpr form CTX. And then if we do def method parse item int, we are going to return, let's do something funny. Let's do form ctx, and we're going to actually return an integer, right? And then if we return the keyword int, def method parse item of, let's see, symbol, then we are going to do form ctx, and we're going to do something fun here. Tell you what, let's return hash maps on those. Kind of making this up as I'm going along, if you haven't noticed. So type is symbol, value is, let's do form. Then up here we'll do the same. Type is int, value is form. So we have our three cases. Now we just need to implement parse sexpr. So def method parse sexpr, and then actually on this one we're going to say if we are handed if, we are going to parse out if, right? So if we are handed a form where the first item is if, because that's what we're doing here, is we're pulling the first item off the form and we're dispatching on that. So if the first symbol is if, then we are going to do, so we have, we don't care what the first item is because we know that's if, test else, and test then else, right? And then we have ctx. And then we're going to return out of this, let's see, let's return type if test parse item test, then parse item then else parse item else, right? So you see we're recursing back into the different forms. We're handed this form, and now we're going to go do something with it, and we're creating a hash map here of this. People who've studied compilers will notice that this is, of course, a AST basically, as abstract syntax tree. So now we can go and do this. This should work. Parse item 42. Oh yeah, we need our context, which we're just going to hand it nil because we don't actually use it. And we have int 42. Cool. If we pass it a symbol like s, we get symbol. And if we pass it a form like this and say if x 42 else 41, ooh, we got a problem here because what happened is that up here we didn't pass in our context. And we'll probably use the context in a little bit for some fun, right? So, boom. So what we have is this abstract syntax tree now. Type, if, test, so on and so forth. And we have this tree of hash maps. So that's cool, right? But, you know, let's, there's something interesting here. What happens if we go and we replace if with when? Ooh, it blows up. No method and multi-method parse expr for dispatch value when. Oh, that's right. Parse sexpr only handles if right now. Now we could go write one for when, but when is a macro, right? So it would be nice if we could maybe macro expand it first. Let's try that. So here in let's see here. Let's do parse item. Let form macro expand form. Let's see what happens now. Ooh, it still fails, but it says no multi-method parse sexpr for dispatch value do. Ah, so it actually expanded it into the if and the do that we looked at earlier, but now it passes for the if and fails on the do. Well, that's simple enough. Let's write def method parse sexpr do. Not do times, thank you very much, Emacs. So what we have here is we don't care about the first item, and we have body. and then over here, CTX, right? So now we are actually going to go and create our hash map, type do body. Now, if we just put body in here, that'll just have the raw form, and we don't want that. So map parse item, but we need to pass the context in, don't we? Ooh, yes. So let's wrap this in a function. Then x, and then we'll do x xctx, and there's probably a better way to structure that. But and then we'll do body. All right. So now if we run this again. No method in multi-method parse item for dispatch value null. And that's because when actually expands into two clauses. It expands into a the then, and then the else is left nil. So what we actually want, says here, we have nothing for parse item. So nil form nil. And then over here, def method parse item nil form CTX. We're just going to do type nil. And then parse item. And this still doesn't work because of a wonderful bug in Emacs that has to do with the fact that, or actually it's an nREPL, where basically once you define a multi-method, you can't change the dispatch function. You have to actually reload the whole nREPL. Yes, it's kind of weird, but whatever, we live with it. This is taking a while to restart. There we go. So, so let's go to nREPL here and go back to our core code here and increase the size here again, and then go so you can say, there we go, ns deep. Okay, excellent. So now we should be able to do parse item and do when t42 and then return that. Boom, it works. So we have, you see here, we have an if. The test is the symbol t, then do, and then we have our bodies, and at the end we have the else with that type of nil. Right? All right, so before we leave today, let's do something a little bit fun here. Let's change this code to count all of the integers. So we're going to count how many integers are used throughout our entire body of the macro, right? And we're going to do that with CTX. So we're going to say that CTX in this case is an atom. So swap CTX inc. So whenever we encounter an integer, we're going to increment the CTX. And that was a mistake there. Okay. There we go. So swap in the CTX, and now if we go over here to parse item, we can actually hand it atom one. Actually, we want to define this outside of here. So let a atom 0, and then we have yes, I know. And then we pass an a, and then we're going to print line a and deref that. So this comes up with 0, which is a bit on the interesting side, is it not? Because I would have expected that to work. Let's look at this a little bit. What's the problem here? So, parse item when t42. Let's just make sure this is right. So it's actually trying to increment it, but it doesn't. For some reason, It's not incrementing the atom. Are we not handing the context through properly to all the forms? Well, looks like we are. And it works here. Well, let's do this as a def a atom 0. Let's do it that way. And then if we go back here, that works. So for some reason, my code up there is not working. Yes, now I know why. Okay, so trivia question for the day. Why is it? Well, the problem is we're using map here, right? That doesn't actually get expanded until we end up printing out the output of this parse item. It's never being printed, therefore it's never being expanded. There you go. So let's kind of force this here. Do all. And there we go. So this should work now. Our original version of this code. Yes, if I do that properly. All right, now if we go up here to this code here, there we go. That works. So let's do something a little bit more fun here with this form. Let's do when t, then we're going to do plus 243 times 532. Oh, we don't have plus, so let's, because we haven't created an override for that yet, so let's do something different here. Let's do a, let's do a bunch of do's just for the fun of it here. And we have 5, so 5 integers, 1, 2, 3, 4, and 5. So a couple other things that are kind of your friend here with this is resolve. Should be what we want. Yes. So resolve will take a symbol and get you the var for that, so you can kind of check and see if something is a valid var. So what we could do is we can have a default case. Let's do that real quick just for fun here. So let's do def method parse sexpr default. So if all the other S expressions fail, then we have f and body, and then we're going to do ctx, and then we're going to do type call. Fn is parse S expression on the head, which is on F. Actually, parse item on F with context, and then we're going to do args as do all. So we don't have that bug again. Map fn x parse item x ctx, and then body. So that should work. So what this basically says is in the default case where we don't know what something resolves to, we're going to call it a call to a function. We're going to go ahead and parse the function, and then we're going to parse all the args and assign them to args. So that allows us to do something like this: parse item, and we are going to do this time plus 1, 2, 3, 2 and 3, atom 0, and this is what we get back: call. And the function is of type symbol plus. The args are an integer of 2 and an integer of 3. Now there's something pretty cool about this, and that is we can actually do something like this. We can do comp plus divide, right? Or let's do pause. Pause and plus. Now, what's going to happen here? When we execute this, it's going to look at the function, the first item, and say, well, we're parsing that too. So it'll recurse back into parse item, say, oh, it's a sequence. Now we're going to dive back into here and say, well, it's comp. It doesn't know what comp is, so we're going to have a nested set of call functions. That's exactly what we have. The type is call. The function is again an expression to call, and the function of that is comp, and then it has args of positive and plus. So this is kind of the guts of a deep walking macro, is that by these simple, I prefer to use multi-methods, but you can use a whole bunch of different things. You can write something like this that kind of parses your code and does some things with it. So just for fun, def method, def macro to AST, and let's call this form. You know what? We're going to have this take a single argument. We're gonna do that. It's going to take a single argument and parse item, and we are going to give it form and atom 0. Okay, so we have 2 AST. So now we should be able to do 2 AST plus 1, 2, and we get our S expression out. So there we go. That is really what and we can do even much more, so that we can do when x, if y is less than 100, then y less than otherwise y. And we can't actually use those because those are keywords, and we haven't implemented keywords, so we'll do this. And it's not able to resolve to AST. It's not able to resolve X in this context. And there's a reason for that. And the reason is that we're returning, remember what I said before, we're returning a map, and that map is used in place of the what was before it, right? It replaces it and then evaluates it. So what we really want to do, and we can see this once again, macro expand is our friend. If we quote this, we see, that works. But this is being looked at by the compiler and executed and said, well, what's X? I don't know what X is here, right? It's trying to create this hash map, basically, because it's replaced the contents of our call here with that. So let's do something, just for simplicity's sake, we'll just do apply string to that. And now if we run this, we'll get a string of our of the different pairs. You know what? We don't want to apply string. We just want string. And we'll do prstr just for fun. There we go. So now we have a string printout of the AST of the code. So we could do a whole bunch of things with this. But what the go macro does, and we'll look at this later in our next video, what the go macro does is does something pretty close to this. It emits a weird AST instead of what you kind of see here of nested hash maps and stuff. It emits a very weird AST in what's called an SSA format. Takes that, does some transformations on it, and then turns it back into Clojure code. You can see how we could actually take this hash map here, do a set of, def multi again that looks at the type and dispatches on the type, so if, symbol, so on and so forth, and would actually go and spit out the Clojure code. And we could actually have a macro that reads into form to the AST and spits it back out to the form. Pretty useless, but in the case of the async macro, go macro, that's exactly what it does. Is it ingests it, does a bunch of transformations on it, spits it back out. So that's, I think, all we have time for today. Thank you so much for watching. Once again, my name's tbaldridge. I work for Cognitect. And check out our website. I'll have a link to that in the description. I also will upload this code that you see on the left, and I'll put that as well in the description. Feel free to contact me on Twitter, on through email, or even through IRC. I hang out there a lot on the Clojure IRC. Thank you very much for watching.